Let's take a look at an example that displays to us a linear function. We're going to suppose that somebody has a walking rate of 3 meters per second. So every second that they're walking, they're going to get another 3 meters. That's a consistent rate that's happening over a period of time. Now from that, we're going to be able to come up with 3 things. We're going to be able to fill in a table of values. We're going to take that table of values and put it onto a graph so that we can visualize the function, and then take both of those and create an equation that will display all sorts of information for us. To start, we need to note that it is 3 meters per second. In this table, we start with time 0. Time 0 is the starting point. Okay? If this person's walking 3 meters per second, well, a second needs to go by for them to move 3 meters. So at time 0, they're still going to be at distance 0. But after 1 second, they're going to be able to have traveled 3 meters. And each continuous second, we're going to have another 3 meters. So let me fill this in by adding 3 each time. All right, now we have a table of values. These table of values correlate very well to our graph because they can be considered coordinates. This being kind of our x value, our t values, and this being our y value, in this case our d values. You can see on the graph that my x-axis is in fact time for t, and my y-axis is distance for d. Give me a minute to put these points on here. 0, 0 will be right at the origin. 1, 3 means time 1 and distance 3. Time 2, distance 6. And so on. Now you might be able to tell that as this graph is getting created, that my points are falling in a line. Okay? This is why we would consider this a linear function. The word line is right there in the word linear. Now from this, and really from the rate itself, we should be able to come up with a formula for coming up with all different types of values. Because right now, I just have our first 6 values. What if I wanted to know what happens at time 10? How much meters, or how many meters can they go after, let's say, a minute? Well, it would take a long time to get that far in a table, and it'd take a really long time to make a graph that big to see it. So a nice thing to have is an equation that relates our distance compared to our time. We have just that equation, and it is referring to distance equals rate times time. The amount of distance that you can travel depends on how fast you're going and how long you're going at that rate. In this instance, our rate is 3 meters per second. So in order to write an equation, the only thing we have to do is insert a 3 for that r. Now you might be wondering, why is it important to have that equation? Well, now we can answer some of those things that I asked earlier. What happens after 10 seconds? Well, t is talking about seconds. If we're talking about 10 seconds, all I have to do is take that 10 and put it in for t to see what happens. So my equation would look like this instead. I've replaced the t with the 10 seconds that we're looking for. 3 times 10 give us a distance of 30 meters. And I have that answer without having to create a big long table or a really big graph. One of the other questions I said was, how far would they be after a minute? Well, we're not going to put 1 in here because t is standing for seconds. So we have to do a little conversion, say that 1 minute is 60 seconds, and put that value in for t. 3 times 60 is going to give us a final answer of 180 meters. So we have for ourselves a nice linear table, a nice linear graph, and a nice linear function relating all to this 3 meters per second walking rate.